In this video, we'll solve another ODE by the integrating factor method. So let's recall that in order to use that method, we need to have an equation of this form right here. We have the dy dx. There's a y, so what's p of x? Well, we could rewrite this as dy dx plus 1 over x times y. That would be the same thing as y over x, 1 over x times y. Then we can see the p of x is 1 over x. And on the right side we have x squared, which is our q of x. So now we've got the equation in the correct form. And again, the first thing we need to do is calculate u equaling the integral of p of x dx. Let's do that off to the side here. So we have u, let's see, I'm going to do it clear over here. U equals the integral of p of x dx, which is the integral of 1 over x dx. And the integral of 1 over x, again, remember we don't need a constant for our u, is the natural log of the absolute value of x. But because we're given that x is greater than 0, the absolute value of x is just x. So we just get ln x for u. And then recall that we need to multiply both sides by e to the u. So e to the u is e to the ln x. But of course, e and ln are inverse functions of each other, so this is just x. So e to the u is x. And then notice it says we compute u and multiply both sides of the equation by e to the u. So we go back here and multiply both sides of this by x. We get x dy dx plus, we multiply by x here, x times the 1 over x is just 1, so plus y equals, and when we multiply by x on the other side, we get x to the third. And then again, the left side collapses to d of e to the u y dx. And e to the u is x, so this left side turns out to be d of x y. Okay, that's our e to the u y is xy. And then with respect to x, dx, so this is the derivative of the entire quantity, d of xy. And we don't need our sheet anymore. The right side is still just x to the third. And now we multiply both sides by dx. So we have d of xy equals x to the third dx. And integrate both sides, or take the antiderivative of both sides. So we have derivative, or integral of d of xy equals integral of x to the third dx. And of course, like before, the integral of d of xy is just xy. And the integral of x to the third, let's see, now this has got a plus c, but we know the other side's going to have a plus c, and that we'll subtract this one from that one. So from here on out, we'll just put a plus c on one side. If we get plus c's on both sides from integrating both sides, we'll just put one on the right-hand side, and that will take care of it for us. So the power goes up by 1, x to the fourth, and then we have 1 over the new power out in front. And you can check by doing the derivative. 4 times the fourth would be 1, and the power goes down to x to the third plus c. Now what we'd like to do is we want to get y by itself, so let's multiply both sides by 1 over x times xy. That'll cancel the x's. On the right side we'd have 1 over x times 1/4 x to the fourth plus c. Here 1 over x times x is just 1, so we get y equals. When we distribute this in, don't forget it has to go with both this part and the constant. The 1 over x times x to the fourth will be x to the third, so we get 1/4 x to the third. And then 1 over x times c, which I'm going to write as plus c over x. So that's our final solution then, using an integrating factor for this differential equation. That's the only way we could work this equation. You would not be able to solve this by separation of variables.